Hello student, good morning. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss, already actually I have finished a standard enthalpy of formation, and today I will discuss thermochemical equations. But before going to thermochemical equations, I want to discuss little more about the standard enthalpy of formation. Some values I want to discuss because some questions are asked in almost all examination. Then here 3-4 things I will discussed. First things that actually you have seen heat of formation, that delta H value either it will be negative or positive. If negative means exothermic reaction, if positive means endothermic reaction. But now I have talked about the standard state or reference state. Means here delta H value should be 0. Delta H value should be 0. As for example, I told you in case of S2, it is 0. For carbon, graphite, it is a 0. For sulfur, rhombic, it is a 0. Then whose value is 0, substance whose value is 0, that first to understand, I will tell this thing already I told you. Then whose delta H value, standard heat of formation or enthalpy of formation, the delta H value is 0, then what are the substances whose value is 0? Then because all things what I am going to discuss now, all are asked in a competitive examination, either 1 marks or 2 marks. Then here you understand bromine liquid Br2 liquid, in bracket you can write a small l, okay, its value is 0, delta H value is 0, standard value that is 0, okay. And after that already I told you for the carbon, graphite carbon, its value is also 0. And third, chlorine gas Cl2 gas, in bracket you write G. Here physical state you have to mention essentially, okay, because in a state change also this value will change. That's why it is important to mention the physical state. Then I told you about the bromine, it is 0, bromine liquid, its value is 0. Graphite carbon, graphite, its value is 0. And after that chlorine gas, its value is 0. Then hydrogen gas, its value is 0, means delta H is 0, okay. Then this I have told you whose value is 0, okay, because while solving the numericals, many numericals are asked. This chapter is full of numericals. Then this value you should know, okay. Now this is the first things I told you. Second things, that they will ask which one is stronger, which substance is stronger. Then how will you tell which substance is stronger? Then you can tell on the basis of delta H value. If delta H value is negative, then many substances has negative value. Then the substances whose negative value is more, that is stronger, okay. This is important things I have told you. Whose negative value is more, that is a stronger, stabler, okay. Then here, why it is like this? Because if more heat is coming out, heat of formation is more, it means that substance will be strong. Because during the formation of that substance, 1 mole of the substance, whatever heat went outside, evolved, given outside, that will be stronger accordingly. If more heat they have evolved, then more stronger. If less heat, then less stronger, like that way. Okay. Then heat of formation decides the stronger, and that which substance is stronger, then by the value of delta H, comparatively you can tell which one is more and which one is less stronger. Okay. Then in that sense, 3 questions generally they are asking in this way. Then here I will tell you that that questions what they are asking. In any question, any examination they can ask, either for IIT Advanced, IIT Main. In indirect way they will ask directly, indirectly this question. Okay, medical also. Even for CSI or NET examination also they are asking. UPSC they will not ask, but they are in the sense of a stronger they can ask also. Okay, because we can strong, that is important. Then it is it can be asked in UPSC also. Then here these are things what I am going to discuss now, that is which substance is stronger. Then by seeing the value you can tell. Then some important substance I am telling you, not to all, important only. If you want to know all, then you have to see the chart. Okay, but important things I am telling you. As for example, suppose aluminum oxide is there, Al2O3, aluminum oxide. Okay, aluminum oxide, and after that barium carbonate, aluminum oxide, barium carbonate and calcium carbonate. This you take first example. These are question is asked, aluminum oxide and other two I told you, that is the calcium carbonate and barium carbonate. Then I will come for aluminum oxide also, Al2O3, but first you think barium carbonate and calcium carbonate, which one is stronger? Question is asked. Barium carbonate and calcium carbonate. Generally people will tell calcium carbonate is very strong, just like a stone, it will not break quickly. Generally you should understand all mountain hill area what you are telling, that is made from calcium carbonate. Main constituent is calcium carbonate. Marble is also calcium carbonate. That's why they are very strong. And now here question arises, first question only, that which one is stronger, calcium carbonate or barium carbonate? Both are stronger. Then here you should understand that barium carbonate is more stronger than calcium carbonate. Barium carbonate is more stronger than calcium carbonate. Why? Because delta H value for barium carbonate is minus 1216 kilojoule. Okay, already I told you kilojoule per mole, that is the unit for heat of formation or enthalpy of formation, kilojoule per mole, don't forget. Then barium carbonate, its value is minus 1216 kilojoule per mole, and calcium carbonate, its value is 1206 only, 1206.92 kilojoule per mole. It is slightly less. Okay, that's why barium carbonate is stronger than calcium carbonate. Okay, value you keep in mind. If you have pen and paper you are keeping with you, you can note down also. Okay, calcium carbonate value is minus 1206.92 kilojoule per mole, and barium carbonate minus 12.16 minus 12.16 means 1216 1216.3 1216.3 kilojoule per mole. This value is important, kilojoule per mole. Now I am coming for this aluminum oxide, Al2O3. Al2O3, actually you should keep some pen and paper also. Important things you can note down also. Then Al2O3, aluminum oxide, its value is a very high value. Its value is minus 1675.7 kilojoule per mole. See, then it is very, very strong in comparison to these three. Highest in among these three, it is highest, 1675.7 kilo minus heat of formation. Then you can understand how strong this is there. Aluminum oxide, Al2O3, solid. It is solid. Then I have told you 3 questions they can ask. Okay. Then in any form this question can be asked. If value is given, then quickly you can answer. Otherwise, general way also you can understand which substance is more stronger. If these 3 are given, then you can answer like that. Now again I am telling related to heat of formation only, but its value is around around 900. Okay. Then there also question is asked. Calcium, that example I am telling you, that magnesium hydroxide, MgOH whole 2, magnesium hydroxide, this is a solid. Okay, it is OH whole 2. Okay, it is solid. And other example is silicon oxide. This is also solid. Quartz. What you are telling? Quartz. This is also solid. Silicon. Okay. Then these, out of these two, which one is stronger? Because question they will ask like that way, that both will be close. Answers will be little close. That type of question they are asking. Then here both are, their value is close somewhat. That's why they will ask this also. Either they will give the value or they will ask which one is stronger. Then magnesium hydroxide, its value is minus 924.54 kilojoule per mole. Okay. And quartz, silicon oxide, SiO2, solid, that is also called quartz, its value is minus 910.94, minus 910.94. Okay. Then by seeing the value, easily you can tell that magnesium hydroxide, MgOH whole 2, it is a solid. Yes, you should write in bracket. Okay, its value is minus 924.54, minus 924.54. This magnesium hydroxide is stronger than silicon oxide, because its value, delta H value is minus 924.54. Okay, the second question I have told you comparatively. Now, third important question. So many questions are asking from this. Then third things I am going to tell, that is again related to that value is again somewhat close. Okay, then in that is around 600 and 700. 600 you understand, 700 is other case, I will tell you. Okay, then here in 600 two compounds are there. Two. First you can say that is silicon SiCl4 gas, silicon tetrachloride. Silicon tetrachloride is a gas. Okay, and other is there. Other is magnesium oxide. It is also solid. This is a solid. Magnesium oxide is solid, and silicon tetrachloride SiCl4 is gas. Then which one is stronger? Then silicon tetrachloride SiCl4 is stronger than magnesium oxide solid. It looks that it is a gas, it will be unstable, but no. Silicon tetrachloride is stronger because its negative value, a delta H value is negative minus 657 kilojoule per mole. But for magnesium oxide, this is a 601.70 kilojoule per mole. Okay, then this I have told you, and one more things here. Calcium oxide also, if three are there, first to understand calcium oxide and magnesium oxide. Calcium oxide and magnesium oxide both are solid. Calcium, magnesium belong to the same group also. Then which one is stronger? Calcium oxide and magnesium oxide both are solid. Which one is stronger? This question is asked. Then calcium oxide is more stronger than magnesium oxide. These are the common question they are asking. Okay, then calcium oxide is more stable more stronger than magnesium oxide. Why? Because now you can understand. Okay, if it is stronger means delta H value will be more negative. Yes, that is correct. Minus 635.09. Minus 635. You should keep pen and paper also. Important things quickly you can write down. Calcium oxide solid is stronger than magnesium oxide. It is solid because calcium oxide value is delta H value is minus standard value, heat of formation or heat of enthalpy, minus 635.09. And for magnesium hydroxide, MgO that is solid, and its value is minus 601.70, little less. Okay, then I have told about this calcium oxide, magnesium oxide, and silicon chloride. This is a gas actually, and but it is stronger. Then this I have told you. Last one more question related to heat of formation, which is asked. I am telling you. Okay, then here it is very interesting, and this is now I am telling only for these things negative value. I have discussed only for negative value. Delta H is negative. Now I am going to two things I discussed actually. Delta H is equal to negative, that is negative value, and zero value I told. Now I am going to tell delta H where delta H is positive. Interesting things. Then here actually three things I will tell you. Carbon atom in gaseous state, not in graphite, that is the solid state. Don't confuse. Because question they will ask, always they will ask confusing question. Then carbon they will write. That's why I'm telling you, physical status you have to write just only near that atom, whether it is a solid, liquid or gas. Then here, if carbon is in a gaseous state, then its values is plus 716 plus 716.68 kilojoule per mole. Okay, means endothermic reaction. What I discussed, all were exothermic. Minus means exothermic. Now plus I am going to discuss endothermic. Then only carbon, but if it is in gaseous state G, C in bracket you write G, then its value is plus 716.68 kilojoule per mole. Kilojoule per mole is the unit, just like rupees, kgs, liter. This is also unit, don't confuse in this. Then for carbon, I told you carbon gaseous state, and another I am telling hydrogen gas. Hydrogen gaseous state, only H atom. Atom, I am talking about the atom. H2 is gas. H2 is gas, that value is 0, I will tell you. But here only H, gaseous state, atomic status. Then its value is plus 217.97. Plus 217.97. Hydrogen gas, H, and in bracket write G. Now third, that is the chlorine atom. H atom I told you, chlorine atom, that is in gaseous state, all three in gaseous state, carbon, hydrogen and carbon. Carbon, hydrogen and chlorine, all are in gaseous state, atomic status. Then its value is plus 121.68. Okay, chlorine atom in gaseous state, its value is 121.68. These are the three value I told you for carbon atom, for hydrogen atom, for chlorine atom, not chlorine gas, Cl2, that is the gas, don't confuse. Okay, because in option they will write this also, Cl2 also, Cl also, carbon graphite also, and carbon gases also. You will get confused. Then here I am telling you, you should not be confused. These are coming under the very tough question. This type of question is coming very tough question and is fit for advanced. Okay, advanced level IIT. Then here this value keep, and out of these three, which one is more unstable? Here again see, just like that is telling about more minus means more stronger. Then here more plus means you have to give more heat, then reaction will start. Okay, this you can give, you can compare. Then here you can accordingly you can understand that plus 716 for carbon, it means it is a more heat is required. More heat is required here, heat of formation. More heat you have to supply to get, you can say, this carbon atom in gaseous state. Then and least is chlorine 121, and middle is hydrogen 217. Means if you will supply less heat, then chlorine is there. But if you will supply only 121 kilojoule per mole, then it will convert to the atom, chlorine atom. That is only 121. And H2 is there, and if you want H, then 217 kilojoule per mole you have to supply. And if you can say graphite is there, carbon, you want carbon atom gas, then you have to supply more heat. That is the 716.68 kilojoule. Now, one more important thing I have discussed all the things, but one more things I want to tell you. that why someone is just can say strong and other is weak. Then for all the things, answer for all the things why it is this, then for this you have to see their structure, internal structure you have to see, bond and other things, electronic configuration, all things you have to consider. And then their interatomic, means between the atoms, what type of bonds are there, what type of attractive forces are there, interatomic attraction, also interatomic forces, intermolecular forces, that is that decide the weakness and strongness. Intermolecular forces, intermolecular attraction. If repulsion will be there, more repulsion, less attraction, then the substance will be weak, bond will be weak. General answer I am telling you. If within the molecules attractive force, both will work. Attractive force plus repulsive force, both works. If attractive force will more, then substance will be, bond will be more, stronger. If repulsive force is more than attractive force in the molecule, then that will be weak. In general answer is like this only. Okay, I have given hint. Now I am going to discuss these things, new topic. But before going to new topic, that is the thermochemical equations, one numerical is there. That type of numerical, only one numerical I will tell you, that is very interesting, and this type of question may be asked in examination. Okay, this type, same question they will not ask, but same question they will not ask, same type of question they will ask. Okay, but in 11th like examination they can ask direct question also. Direct question means direct only for 11th direct question, or 12th direct question, but for competition indirect question. You have to think and then answer. Then now I am giving one question that is actually interesting and maybe asked this type of question. Then question I am reading, and then answer is actually very easy. In thermodynamics, question will be wrong, long question. Question in thermodynamics, numericals will be, data will be more, that's why it will be long, but answer will be short. Then you should not can say, by seeing the question, you should not think that it is big question, I can't solve. Don't be fear from the question by can say seeing their length may be more, question length may be more, but answer will be short, question will be long. Hence you should read the question. If you want to score highest marks, all marks you want to score, then you should not escape from any question. You have to answer all, but you should, while reading, you should be careful. The now question I am telling you, it is not very long, but okay, medium. Question is like that: a swimmer coming out from a pool, a swimmer coming out from a pool is covered with a film of water weighing about 18 gram. Just like we are taking bath, then some water will be added with our body. Like the same situation is there. A swimmer coming out from a pool is covered with a film of water weighing about 18 gram, 18. How much heat must be supplied to evaporate this water at 298 Kelvin? Temperature they have given, it's normal temperature. He is standing, means in a normal, just like in daily we are going outside, then that temperature is 25 degree roughly, 290 normal temperature. 273 plus 25, 298 Kelvin. Calculate the internal energy of vaporization at 100 degrees centigrade. Again I am reading the question. A swimmer coming out from a pool is covered with a film of water weighing about 18 gram. How much heat must be supplied to evaporate this water at 298 Kelvin? Because you have to dry, then how much heat you have to give? You are wet and you want to be dry, then actually for drying how much heat is required? How much heat is required? Calculate the internal energy of evaporation at 100 degrees centigrade. Here hint is given that assuming steam behave as an ideal gas. Okay, just steam, because 100 degree you are talking about, you have to calculate the internal energy of evaporation at 100 degree. 100 degree means steam, then that steam you can consider as an ideal gas. Then how will you solve? Then internal energy you have to calculate. And what they have given? Then amount of water they have given, 18 gram, nothing they have given. Okay, only 18 gram water they have given. And they are asking to, question is that you have to calculate the internal energy of evaporation at 100 degrees centigrade. Then one data they have given for this, delta H evaporation they have given. A standard means a standard in enthalpy. Standard enthalpy for water they have given. Evaporation, heat of evaporation, enthalpy of evaporation they have given for water at 373 Kelvin. Value is given 40.66 kilojoule per mole. Means delta H evaporation value is given. Okay, at 373 Kelvin, means 100 degree more they have added, 273 plus 100, 373. Then delta H evaporation value is given. And then two things they have given. First, delta H evaporation value they have given, and amount of water they have given. Two things they have given. Okay, then you have to calculate the internal energy of the evaporation at 100 degree, means 373 Kelvin. Then how will you calculate? Then see, its solution is, answer is very easy. 18 gram liquid is there. Water means what? Liquid water. You are wet with water. Then 18 gram water you want to convert into vapor. Means 18 gram liquid you want to change to 18 gram H2O gas. H2O gas or vapor. Here according to the question you have to consider as a gas only. 18 gram water you want to convert to 18 gram gas with vapor, 18 gram H2O gas. From liquid to gas you want to convert. This is called vaporization. Then 18 gram water means how many moles? Number of moles of water. 18 gram means, it is very easy. H2O means 16 plus 2 into 1, 18 gram. Molecular mass of H2O is what? H2O means 1 into 2 plus 16, oxygen for oxygen 16 atomic mass. Then 18 gram. Then 18 gram is 1 mole, means number of mole is 1. Okay. Then you know that it is very easy to convert number of moles. If mass is given, then divide it by molecular mass of that substance. Then here water is there, 18 gram. Then divide it by molecular mass of water. Then molecular mass of water is 18. That 18 by 18, that is a 1 mole. 1 mole only. Then the number of mole you have considered 1 mole. Then after that, many times I have told you relation. You want to, you can say, convert internal energy, that is the delta U. Delta U you want to convert. Then delta U is equal to, already I have told you relation, delta U is equal to delta H minus P into delta V, or in the place of P into delta V you can write nRT also. nRT also means delta N RT you can write. Then directly you got the relation that delta U means here vaporization, heat of vaporization. Okay, delta vaporization you can write. Then delta is equal to, now you got the relation delta H minus delta nRT. Correct? Always you keep this relation that delta U is equal to delta H minus P into delta V. And in the place of P into delta V you can write delta nRT, because PV is equal to nRT according to the ideal gas equation. Then now direct relation is there, that delta U is equal to delta H minus delta N RT. Then here all things here knowing, delta H value is given. Delta H value is given 40.66 kilojoule per mole, and delta N is equal to only 1 mole. No change. 18 gram was there, now it is converting to 18 gram. 18 gram liquid is converting to 18 gram gas. Hence number of mole will be the same, 1 mole only. Hence delta N is equal to 1. R value already you are knowing. T is also you are knowing. T is already given 373. 100 degree centigrade means what? 273 plus 100. That is the 373 Kelvin. Okay, 273 plus T, that is the K, that is equal to, after that adding T it will convert into K. Then here T is equal to 100 degree. Then 373 Kelvin, that already given in the question, 373. Then you put all the values, means delta H value you put, that is already I told you 40.66 kilojoule per mole it is given. And R value you know 8.314. Correct? N value is 1. N value is 1. R value is 8.314 joule per Kelvin. And temperature is 373 Kelvin. Okay, 373 Kelvin. Then here all value is given. Delta H value is given, N value is given, T value is given. Only these three value you want. Only these three value, delta H value required is given. Delta N value is 1 mole. R value is 8.314. T is equal to 373. All values given. Then just you simplify it. After writing the value, you simplify it. Then delta U, that is in energy, internal energy. Then that value, after solving all the things, you will get 37.56 kilojoule per mole. Okay, per mole. Always you write in the, all energy has same unit. Okay, per mole, because it is related to the substance. Hence per mole. Mole is the, you can say, a standard. That's why per mole it is written. Okay, just like 1 molecule na, per mole bigger unit. Then I have discussed these numericals. Many numericals are there, but here I have discussed, I am discussing, or I will discuss only very important. Okay, after that I will try to send some numericals and the end of the finishing this all one more chapter is remaining, chemical equilibrium. After that I will try to send some only numericals for IIT mains, IIT advanced or medical. Okay, and the end I will send. Okay, then now I have finished these things. Now I am coming to the, you can say, thermochemical equation. Thermochemical equation. What is that? I want to tell about that, because in solving the numericals in thermodynamics, first you have to understand the question. Only then you can answer, and you have to not fear from the question. Then they will give the thermochemical equation, and then only then you can answer it, can give the solution of the problem. Then what is the thermochemical equations? Then a balanced chemical equation together with the value of its delta H R means a small r, delta R H we are writing, means R means heat of reaction. In a general way, in a common way, last class also I told you heat of reaction, and in a particular way you have to give the name of the reaction. Okay, name of the reaction or process like combustion, formation, vaporization, fusion, correct? Like that you have to write, that is the individual particular case, but in general reaction. The reaction is denoted by a small r. Then a balanced chemical equation together with the value of delta H means heat of reaction, delta RH you can tell, is called a thermochemical equation. A balanced chemical equation together with the value of its delta H is called a thermochemical equation. We specify the physical state. Here you have to specify physical state, that is also called allotropic state. Allotropic, just like a carbon I told you, carbon graphite. Okay, carbon also exists in diamond. Then here allotropic form you have to write, and like a sulfur rhombic, sulfur yellow, black, also many sulfurs are there. Then you have to write a physical state in bracket. Then here, then that type of equation is called thermochemical equation. You have to mention the, you can say two things you have to mention: physical state. First reaction you have a balanced equation, first things. Second things, physical state. Third things, delta H value. Delta H value either negative, positive, 0, whatever be. Then here example I am giving. By one example all things will be clear. Suppose C2H5OH, liquid, ethyl alcohol, you know, it is liquid, ethyl alcohol. This is used in wine. Wine main constituent is ethyl alcohol only. Okay. Then ethyl alcohol C2H5OH is liquid. Then C2H5OH plus oxygen, that will give you two product. When ethyl alcohol and oxygen will react, then it will give two product. Then after arrow sign you can write products, means it will give carbon dioxide and water, liquid water it will form. Then you have to balance it. Then balancing means here balanced equation I am telling you, C2H5OH liquid you have to write L, okay, plus here 3 O2 is required, 3 oxygen, O2, 3 O2 gas. Then after that arrow sign, product you have to write two product I told you, then it will form carbon dioxide gas. Then you write a G, a small g, and balanced equation that 2 CO2 it will form, 2 CO2, 2 mole of CO2 plus 3 mole of H2O. Two products it is forming, carbon dioxide and water. Then 2 mole of carbon dioxide and 3 mole of H2O, liquid, L you should write. And delta H value is minus 1367 kilojoule per mole. Delta HR means heat of reaction, enthalpy of reaction, both are same. That value is minus 1367 kilojoule per mole. This is the actually example of thermochemical equation. Okay, already previously also we have told you. Then here two important points you should know, three important points you should know. Okay, then I am telling that important point, because generally a student will get confused, they are doing wrong things. Here actually what example I have given, ethyl alcohol plus 3O2, this is actually combustion of liquid ethanol. This reaction is called combustion of liquid ethanol. Okay, means it will burn at constant temperature and pressure. This reaction takes place at constant temperature and pressure. It is called, you can say, combustion of liquid ethanol at constant temperature and pressure. And negative value is there, it means it is exothermic reaction. The negative sign of enthalpy change indicates that this is an exothermic reaction. Now, it is necessary to remember the 3 points I will tell you. Then first point is that important point, coefficient. Coefficient, before the molecule you are writing the coefficient in balanced equation like 3O2, 2CO2, 3H2O. You have written, if nothing is written, it means 1. As for example, C2H5OH. Nothing is written before C2H5OH means 1. Plus 3O2, then 3. Product is 2CO2 means 2. Plus 3H2O means 3. This 1, 2, 3, whatever we have written, that is called coefficient. That is called coefficient. This is the first important point. The coefficient in a balanced thermochemical equation refer to the number of moles. Means 1 mole ethyl alcohol, 3 mole oxygen, 2 mole carbon dioxide, 3 mole H2O. Okay, the coefficient in a balanced thermochemical equation refer to number of moles. Again here you understand, never molecules. You can't tell molecules. Student will tell, many student will tell molecules. No, that is wrong. What is the correct? Moles. That indicates a number of moles. You can't tell molecule. Okay. Number of moles of reactants and number of moles of products. This coefficient tells about the moles, number of moles of reactant. As for example, 1 reactant means 1 mole ethyl alcohol, 2 mole, 3 mole oxygen. These are the reactants. And products, 2 mole carbon dioxide, 3 mole water. Product. Okay, not molecule. Important things. Second important point, I am going to tell you that when a chemical equation is reversed, the value of delta H, value of means heat of reaction R, delta R H is reversed in sign. Then if you will reverse, then sign will also reverse. Means negative will become positive, positive will become negative. As for example, N2 plus 3H2, N2 gas, nitrogen gas, N2 in bracket write G, a small g, plus 3H2, again in bracket write gas. These are the reactant. And what are the product? Ammonia gas. After the arrow sign, you can write 2NH3, N2 plus 3H2, it will form 2NH3. NH3 is also gas. Here all three are gas. Nitrogen in gas, hydrogen in gas. Then nitrogen and hydrogens are reactant. And what is the product? Ammonia gas. After arrow sign, you write 2NH3. And in this reaction, heat of formation or enthalpy change is negative. Means 91.8 kilojoule per mole. Delta H value is minus delta RH. Delta RH value is minus 91.8 kilojoule per mole. This is the balanced equation. Then if you will reverse it, means right side, you have, now it is 2NH3 right side, and N2 plus 3 is left side. Now you reverse it, 2NH3 right left side and N2 plus 3H2 right side. Then this delta H value will, sign of delta H value will reverse. Means now it will come from minus, it will become plus 91.8 kilojoule per mole. Okay, this 2 point I told you. Third point, that is you have to understand, that is very, very important. Third point. Okay, here this third point will be used in solving the numericals. The numerical value, third point I am telling you, the numerical value of delta H. Numerical value of delta H refer to the number of moles of substances. Moles of substances. Okay, not only one mole, maybe more than one. Moles of substances is specified by an equation. Okay, whatever balanced equation is there, and in the end you are writing delta H, that is for that reaction. Here again I am telling you, delta H value is not only referred to the heat of formation. Now in this case, whatever example I have given, ethyl alcohol plus oxygen, it is giving carbon dioxide as ammonia, water. Then this is the two products are there, not only one product, two products. Hence you can't tell formation. It will come simple way, general way you can tell heat of reaction. If only one product will be there, that time you can tell. That time you can tell formation, and in that also it should be from their elemental state. Elemental state means in which state they are existing. In which state they are existing, that is called elemental state. Okay, Cl2, H2, carbon, graphite, sulfur, rhombic, already I have told you. Then here this is important things I have told you. Okay, then if 2-3 products are there, then you can't tell that heat of formation. Because 3 products are there, how will you tell heat of formation? Heat of formation is related for only one product. Only one product. Then for individually it may be possible, individually not for in a reaction. Reaction when 3 products are there, 2 products are there, then you can't, question does not arise. That time you can tell only heat of reaction. Then now I am giving one more example to discuss third point, that in this I have told you that numerical value of delta H, delta RH refers to the number of moles of substances specified by an equation. A standard enthalpy change will have a unit, already I told you, as kilojoule per mole. This is the right place to tell unit, kilojoule per mole. Okay, all energy term is represented by same way, kilojoule per mole. Kilo, that is the 1000. For the 1000 you are writing K. Joule is the unit. Then per mole, any substance you are telling about energy, then how will tell you? Just like you are telling per rate, you are going or asking what is the rate of this vegetables, then they will tell 40 rupees kg, 50 rupees kg. Then like that way, here that kg you are using the term of mole, per mole. Okay, then kilojoule per mole unit. Now one example I am giving you, then I will explain you. This is related to calculation. Then one example reaction I am telling you, balanced equation. Fe2O3, that is a solid. It reacts with hydrogen gas, H2, 3H2. It balanced equation I am telling you. Fe2O3 reacts with 3H2. H2 means gas. Then it will give 2 products. After the arrow sign, you can write 2 products. 2Fe means iron, that is a solid, plus 3 moles of liquid. It will give 3 moles of liquid, means 3H2O. In bracket L you can write. Then Fe2O3 solid plus 3H2 gas, and it is giving 2 product, 2Fe. And another product is 3H2O plus 3H2L. Then now here, suppose you want to calculate heat of formation or heat of enthalpy. Already last class I told you same concept means delta H, then but here I want to tell you, already I have discussed before starting, only in the beginning, so many delta H value of the different substances I have told you. Okay, then one standard chart is there, a standard chart. In that you will get all value, all substances. For all substances, what is the delta H heat of formation value, it is given. For all important substances it is given. I will try to send. Then from that you can get, for each substance you will get the value for a standard heat of formation, Okay, then all values you will get. Then here delta H value for this reaction, how will you get? Then same formula what I have discussed in the last class, that is the delta H heat of formation or enthalpy change in the reaction. Then for that, delta H is equal to, again I told you, a sum of the heat of formation of all products. Sum of the heat of formation of all products minus sum of the heat of formation of all reactions. Both are reactant side, product side, heat of formation. Just to add it, its value you put, and after that do simplification. Very simple things. Means sum heat of formation, sum of the heat of formation of products. First you write product, then minus you write sum of the heat of formation of reactants, product minus reactants. Okay. Then all value will be given to you. You will get, or in question they will write. Then last class I have told you. Then same way here you have to write. Then here for Fe2O3, value, that is a very high value is there. Fe2O3 value, actually when you will solve the numerical, then automatically you will remember that value. In the beginning it will look that how will you remember, but if you will solve the numerical, then something will be repeated, then you will remember. Then delta H heat of formation, that value is for Fe2O3, that is solid, that value is minus 824.2 kilojoule per mole. 824.2 kilojoule per mole. Then Fe2O3, its value is knowing, and hydrogen is 0. Already I told you, hydrogen value is standard heat of formation of hydrogen is, already I told you, 0. Correct? Then product side you are knowing, reactant side you are knowing, and product side iron. For the iron, what is the value? For iron is just stable, you find iron only in Fe form, then its value is also 0, just like a carbon graphite, 0 is there, sulfur rhombic is 0, like that way iron, because it is existing in the iron form. Then whatever, any substance which is existing in that is what is that value, that is considered as a 0. All gases will be generally 0, but unstable gases will be not 0. Unstable gases which can quickly, as for example carbon dioxide and other gases which can change their state quickly, means they can convert into liquid and solid. There for carbon dioxide it is not 0. Okay, ammonia gas it is not 0, but permanent gases, for that it is 0. Then now delta H, iron, that its value 0, and for water its heat of formation, that is the minus 285.83 kilojoule per mole. Always per mole you have to write. Then all values you are knowing, for 2 reactions, 2 product, all values you are knowing. Then first you write make the sum of the products, and then minus sum of the reactants. Then product only Fe2O3 is there, only 1 mole. Then its value Fe2O3 value is minus 824.2 kilojoule. Then 1 into 824, you have to multiply with coefficient, minus 1 into minus 824.2 plus other. For iron you have to write, for the product first you write. Then for iron it is 0, then 2 into 0, 2 Fe means 2 into 0 plus 3 molecules of water is there. Then 3 into for H2O value is 285, minus 285. Then 3 into minus 285. This is for product side. Minus, now reactant side you have to write. Then 1 mole Fe2O3 is there. Then 1 into 824, because Fe2O3 value is minus 824. Then 1 into 824.2 plus 3H2. Then 3 into 0 plus 3 into 0, because H2 is 0. Then after the solution, solving it, you will get final result, that is minus 33.3 3 kilojoule per mole. Final result you will get minus delta H, heat of the reaction. Heat of the reaction means delta H, that is equal to minus 33.3 kilojoule per mole. Here always you have to use the per mole. One term is there, you should know. Generally a student will not know. 90% student will not know. Okay. Then what is that things? That first you should know that the coefficient used in this calculation, coefficients used in these calculations are pure numbers. It is a number 1, 2, 3, 4 like that, which are equal to the respective stoichiometric coefficient, that is called stoichiometric coefficients. Okay, first things. Second things, already in unit they know. The unit for delta H is kilojoule per mole, that no. But what is its meaning, that you understand, that the student will not know. They will get confused. Which means kilojoule per mole, which means per mole of reaction. Per mole of reaction. Okay, this term is new, per mole of reaction. Once we balance the chemical equation in a particular way, as above what I have discussed, this defines the mole of reaction. Mole of reaction. Okay, this term is new. Both terms has same meaning. Same meaning. Mole of reaction. Why mole of reaction? Because reactions are going in a, according to the moles. According to the moles. Reaction is going according to the moles. Means here that 1 mole of these things, ferric oxide. Actually ferrous, ferric, you understand, APO is a ferrous, plus 2 plus is ferrous, and Fe2O3, then here AP2, this 2 is telling for oxygen valency, oxygen is 2 valency, minus 2, and 3 cross way, Fe2O3, then 3 is telling about the ferrous, Fe plus 3, then this is the ferric oxide, and FeO is the ferrous oxide. Then here, because reaction is going on the basis of a mole, not the molecule, that's why reaction is called mole of reaction. Mole of reaction. Now, then balanced equation, what I discussed, that was the balanced equation. But now, if you will make it half, quantity you are making it half, then obviously when quantity is reactant, you are taking half of the initial, half mole, means half, whatever you are taking requirement is different, but if you are taking half, what I discussed now, then half value you are taking, you divide half left side also, from 2 you divide from both sides, left side also, right side also, then quantity will be half, reactant is becoming half of the beginning, then obviously product you will get half of the beginning, then obviously heat evolved, whatever heat will come out, that will be half of the beginning, but both have same meaning. If you can say in 10 rupees 1 kg you are getting anything, then in 5 rupees half kg you will get, then meaning in your rate is the same. In 10 rupees 1 kg, then in 5 rupees half kg. The same meaning is, that means it is a quantity of heat is becoming, heat which it was coming out also becoming half. Then this proves that this is the extensive property, extensive quantity. It shows the enthalpy is, because amount is, this heat is depending upon the amount. Extensive property means what? That depends, value depends upon the quantity, mass. Then here see, if mass was more, heat was evolving more. If mass is less, heat is evolving less. Hence, it proves that enthalpy is an extensive quantity. Then here either you consider for half mole and 1 mole. that is only, it is called molal, defines as a mole of equation, mole of reaction, you can tell, mole of reaction or per mole of reaction, both are same. Mole of reaction, per of mole of reaction. Rate is the same, 10 rupees per kg. Either take 1 kg, half kg, 2 kg, 3 kg, but rate is the same. That's why this value will vary, delta H value will vary accordingly. Okay. Then now today I am stopping only here. Next class again we will meet you. Thank you.